Let's start this today's Lunchtime Tech Session, brought to you by Canterbury Tech. I'm Andy Masters, and I'm speaking with Nataliia Mikhailova, who's a solutions architect from AWS. Nataliia has been a solutions architect there for 2.5 years. And today she's going to be presenting to us empowering AI to act, agentic capabilities of Amazon Bedrock. And if you just caught the conversation, we were just chatting about large language models and some of the things that we've been trying out ourselves. So large language models have shown impressive capabilities in communication, creating content, and task assistance. But their potential can be enhanced further by actually enabling them to interact with various systems and data sources within an organization. And today, Nataliia is going to be talking to us about Amazon's Bedrock Agents feature, which addresses this need by providing a fully managed solution that allows AI applications to perform complex multi-step tasks across different company resources. So we're going to dive into AI agents and how we can use them to create more powerful and efficient AI applications. We'll discuss the benefits of agents to streamline operations, improve decision-making processes, and enhance user experiences. This will cover the basics of creating and deploying agents, best practices for integrating them, and potential use cases for all of you guys listening across the whole of Canterbury. So let's get to the next slide. So a big thank you to our Canterbury Tech annual sponsors. We have the UC Business School that brings us the most relevant MBA program and executive education program in the country. It has a subscription service, so you can eat as many courses as you like and binge out rather like Netflix. And also we have AWS, who need no introduction. They're known for their infrastructure services, but they're also a bunch of friendly people, and they can provide assistance for businesses with knowledge in pretty much any area that's technical. We also choose to use the services of our annual supporters. So we have Ridiculous Digital, which help us improve our SEO and Google ranking. Crescent Consulting, which helps us with recruiting, and Shorthouse Consulting, our marketing experts. So let's get to know the audience. Let's use the emojis and have a bit of fun. One of the top tips for emojis is, and I didn't know this, is you can press the Windows dot button on your keyboard, and that will open the emoji picker. And from there, you can choose whatever emojis you like. So be free, choose your favorite emojis that represent the mood that you're feeling right now, or you can be a conformist and you can choose from the pre-selected menu of emojis on the slides at the moment. So let's hear from the audience and see what's happening for everybody in the audience. We've got Kaylee, who's from Christchurch. Louisa, Ferdinand, anyone from outside of Christchurch in the audience? And let's see what your mood's like. You had a better day? Are you so-so, or are you kicking it out the park? Jeff's got a sheep emoji there from TyTap. We've got the folks from Custom D. And Gillian's having an awesome day. So yeah, big welcome, and thank you very much to the audience for participating. It's your attendance that makes these things possible, and I think we've got quite a large audience for today's session. So without further ado, let's proceed. So a few shout outs about upcoming community events. We've got the UX meetup. They're going for an unconventional fireside chat with Alan Cox, where he's going to share his fascinating journey and explore various topics like conflicts, ethics, and why even the best UX doesn't guarantee success. Expect an engaging conversation and thought-provoking insights. I personally know Alan. I know he's a generally all-round good chap, and I think that will be a very interesting chat to go along to. So that's on October the 17th at 5 o'clock at Made Curious. Now we have a lunch and learn session with Ari Clark. She's going to bring you essential tips of successfully expanding your business into the UK market. Don't miss out on the key insights that can make a great difference to your business. I'm from the UK originally, so I know the challenges that people might face trying to expand into the UK. So excited to invite you guys to lunch and learn. And yeah, there'll be some specialist advice alongside with drinks and nibbles. So check them out at the Epic on October the 22nd at lunchtime, 12 to 2. And finances, obviously in the news at the moment with the base rate coming down, but there's also the FinTech Meetup. The team at Duncan Cotterill graciously offering their office space for the next event. And they'll be discussing the consumer data rights that the government is currently establishing and how they're going to impact on your business. This bill is currently with Parliament, and it allows businesses and individuals greater choice to control their data. Probably that means more competition and lots of interesting fintech opportunities. So check out the FinTech Meetup at Duncan Cotterill on November the 19th from 5 till 7. And don't forget our actual in real life sessions on Tech Tuesdays. That's coming up on November the 5th. This time we'll be talking with James Graham about building realtor.co.nz. A practical journey of innovation and balance. So James began this project with a clear goal to fill a gap in New Zealand's property market by creating a user-friendly platform that supports Kiwis through every step of their property journey. And so in this presentation, he's going to take us through the development journey, focusing on the practical and technical solutions to the day-to-day challenges. And there certainly were some, he says, along the way. So looking forward to that. James's background, he's got over 15 years experience in business and analytics, and he's directly contributed to over $100 million in sales revenue. So, yep, check that out on Tuesday, the 5th of November at the PwC Centre in the centre of town at Cashel Street. So, at this point, I'll kindly hand over to Nataliia and we can get started on agents. So Nataliia, I'll invite you to share your slide deck and we'll go from there.
Sure. Can you stop sharing so I can take over?
There you go.
Okay. Share. Cool. Can you see my screen?
Yeah.
Awesome. Thank you. Hi, everyone. My name is Nataliia. Thank you very much for that introduction. And I'm a solution architect at AWS. I'm based in Auckland, New Zealand. And I'm very excited to be here today and have a conversation with all of you about building generative AI application with agentic capabilities. So we're going to start with a kind of agenda to have a little bit of structure to that presentation. First, I want to start with why do we actually start thinking about agents, and then move into how to build Gen AI application with agentic workflows on AWS. Some consideration for building these workflows on AWS, and different approaches as well for building workloads which have a similar capabilities, agentic workloads. And I'll finish up with some resources for you to get started on AWS. But before we dive in, I actually want to start with this quote from professor from Harvard Business School. While I have quite a few conversations with the customer recently, the question come up quite a few times is like, am I thinking that AI is going to take our jobs, replace human? And my answer was generally, no, I don't think so. I think the way we work is going to change. And this quote is have a pretty much similar semantic, where AI is not going to replace humans, but humans with AI is going to replace humans without AI. And I believe the AI is changing the way we are working and how we interact with world nowadays. So let's start with agents. First, let's define what is an agent. AI agent is a software program that can interact with its environment, collect data, and use data to plan and execute tasks to meet user-defined goals. If you think about Gen AI models or foundational models or large language model, the model itself cannot perform any actions. Model does not have any memory. Model can only respond with something when you send request to it. And originally, when model came a couple years ago, people were very fascinated that you can have a chat with the model and it replies and it sounds like a human. It's not really defined workflow. But over time, people start thinking, oh, yes, this model been trained and it sounds like a human, but it doesn't know anything about my company. It's not aware of information in my company. So people start thinking about how I can make sure that model can tap into the information of the company. The application been built around the models to manage this conversation, the history of conversation again, because model itself does not have memory. And nowadays people are moving into, okay, cool, model can go and I can give information about my company, but it's still not the same as somebody doing the task or work. Model cannot do the action. So yes, it gives me a text and I have to do something about it. How can I incorporate something around that model which actually can help me with doing actions? And now, while it's all started with basic chatbots, it moved much beyond that point. Nowadays, Gen AI application can not just do some lookup data, but actually can go and connect to other systems, get information to other systems, put information to other systems. And it can benefit in many ways because you can have full user context. It can help you do your task faster, and it's all done in natural language. So with agentic capabilities, you now can plan and execute much more complex tasks where there are no predetermined flows. From the customers we see working in this space, there are few use cases, and while you can kind of sort them in a different format, I like to look at them from the time perspective, how real-time response need to be from the agent, because that would be one consideration when you build in such systems. And here, for example, you can classify them into three type of use cases. The real-time use case, where it's actual chatbot, where you interacting with something and you expect that the feedback to the question you said, some kind of sentence, will be pretty much real-time synchronous. And these workloads will be very, very latency sensitive. Now, if you move away from this real-time interaction conversation sort of situation, where you have more like a task-based approach, a task-based agent, even if it's a human and you ask them to do something, you do not expect that they can do it like, instantly. If you ask them to create a report or kind of itinerary or something like that, it will still take time for human to perform. So similar with agents, it can be accepted that this task-based agent can be near real time, but still will take some time. And moving away from real time, we have more like autonomous digital workers or companion, which I've seen been used a lot in the development sort of world where you have a big code base, where you want to do major transformation, code migration, etc., it's going to take time. If you want a human to do it, it's going to take a lot of time. So the agent, you can ask to go and do it, and you can leave the agent go and do this task and come back to it once it's finished. So the expectation from what agent provides to you, how fast it applies to you, is very, very important when you build a system, because you're trying to make sure that systems matches customer expectation. Now, obviously, we want to have some benefit of using technology. And what we see benefit in customers most with using Gen AI capabilities and adding agentic functionality on top of it is actually improving customer experience, because now it's not just, here's a piece of information, go do something with it, but it's actually agent do something on behalf of the customer. It can help with more effective decision making, again, by bringing more information from different systems. So you can kind of get to decision making process instead of finding information for your decision, which lead to increasing productivity and reducing cost. And that, from business point of view, is why customers and other organizations are kind of investing a lot of effort and money into building this new application with these new capabilities. Moving on to how to implement something like that on AWS. First of all, we do have a service called Amazon Bedrock, which is an easiest way to build Gen AI application on AWS. It's a fully managed solution which provides you access to multiple leading foundational models via a single API. And it has a lot of other additional functionality. One of them called Amazon Bedrock Agent. And it enables generative AI application, which you build, to execute this multi-step business task. And all you need to use is natural language. Now you can build application which dynamically plan and execute the task that customer can send to you. Because you build it on AWS and it integrating with AWS other services, et cetera, you have all the security and privacy leverage and built-in mechanism which is available for you on AWS. And you can automate a lot of things and integrate a lot of things. As a fully managed solution, you don't need to worry about a lot of things which is happening behind the scene. And things which are actually happening behind the scene is things like, again, model itself cannot access anything. It is not aware of APIs or other systems in your environment. So you have to specify what agent is able to do, which action it's able to perform. If you have specific knowledge base data store, you can connect agent to specific data stores to allow agent to look through these data stores. And things like handling, storing memory data about the conversation, storing session data happening behind the scene on your behalf, and you don't have to worry. You don't have to decide which data store you need to use to store all of this data, how to integrate to make sure that nothing has been lost. That's why it's kind of coming as a fully managed solution. On top of it, we have a feature called guardrails, again, with Gen AI machine learning models. Foundational models can hallucinate and can generate something either inappropriate or something which you don't want your application to talk about. Because, for example, if you have a chatbot about, I don't know, insurance, you probably don't want it to talk about finance services or politics or cars. So you can build some additional level of protection using guardrails. Now, let's dive into actually flow or diagram how it's work behind the scene. So agent will provide some orchestration on top of Gen AI model. So when customers send the task to the agent will consider a lot of things. It consider all the information which was provided to the agent while the agent was built. It will send information through the guardrails to make sure there is nothing inappropriate and all in defined boundaries. It will provide instruction, any information about conversation history, memory, and task description, and it will send to one of the foundation models on Amazon Bedrock. That Amazon Bedrock, or one of the foundation model which you choose for your agent, will think, and using chain of thought prompt engineering technique, will come up with step-by-step plan, which it will start executing. So if it decides that it needs to do API call to get some additional information, it will do API call. If it decides that it needs to go and access to particular knowledge bases, it will go and retrieve appropriate information from knowledge bases. Again, it's not like it's designed by itself. You have to specify information where this agent allowed to go and which information it allowed to access at the step where you originally built this agent. Once all the steps complete, it will send results back to the agent, and agent will, again, send the task and the results to foundational model to generate a final response, which again, if you have some guardrails set up around your agent, will go through guardrails to verify that the response which model provide adhere to your rules. And this final response will be given to the customer. As you can see, there are a lot of moving parts behind the scene. And from the customer point of view or from your developer point of view, you're only in control of defining that agent and what it can and cannot do. But everything behind the scene happens on kind of automatically. There is additional capability where you can return control to the application instead of doing API call, like agent doing API call on your behalf. Again, this has been added relatively recently to Bedrock because you not always want it to be completely automatic and do all of the things on your behalf. Now, because there was some of the concerns if agent kind of go and do all of this on your behalf, that might be not what customers want. We added additional capability to confirm with the customer before taking action. Again, when you call customer support, sometimes they say, okay, we're going to do this, this, and this. Are you okay with it? So they are confirming with you that the action that they're going to do with your account or with your problem, you're okay with it. So you can implement something very similar with agents on Amazon Bedrock. Another cool feature of Amazon Bedrock agents, which again, quite a recent addition, but I'm quite fascinated about this one, is how it can manage summaries of the conversation and the memories intelligently. For example, imagine you have a conversation with the agent to do something, like in this example, it's booking a trip. So it would be a lot of back and forwards. And once conversation is finished and agent the book that trip for you, do you really need all of this step-by-step conversation? If, for example, later on you would need to come back to it? Probably not. And this is where we can use summarization of the conversation and storing that just a summary of the conversation when the session ends. Like imagine you come back later on and you want to do some changes. Probably the summary of that conversation, if whatever existing booking exists, is enough. And it's not just going to kind of make everybody's life easier, but also, again, you need to store that conversation. So it is a storage space, storage cost. Every time you send the conversation to the model, this is tokens, which is model consumed. So it's, again, that's a cost to run that model. The more context you send, the more expensive this call becomes. Now, you can still provide this accurate information and all the required context to the model without keeping the original conversation. Thinking of a human doing something like that, again, if you contact the agent to do the changes, they're probably not going to go through entire conversation line by line to evaluate what was discussed last time. If they have that summary feature in the system, they probably go look at summary and look at the booking and then continue conversation. Pretty much Bedrock automated this kind of thing for you, and you can use it as a managed solution. I found this very fascinating. Some guidance and things to consider when you're building Gen AI agentic workload on AWS or in general. With customers who build it, what we see, it's not like they come up with a solution and out of the box it's all working. No, it's kind of went through quite an iterative process where customers started with problem definition and some results customer want to achieve. Then they build an agent, observe a behavior, compare results to what they expected to come back, modify the agent, and again, going through the loop again and again and again until they get to the point that they're happy. With LLM being non-deterministic in nature, there is an expectation that results will be different from turn to turn, and that's okay. And you need to be okay with this, because if you want 100% deterministic output, Gen AI and any machine learning is not really the right approach, because it always have a chance of providing, the wrong answer. Just kind of do not expect to, if you haven't played with agents before, just kind of go and be able to have a production ready system in one iteration. Like it would probably require a few iteration steps on your behalf. Another thing to consider is about, again, because Gen AIs and foundational models are non-deterministic, is for your use cases, what would be your agent accuracy and consistency requirement? When we talk about accuracy, we're talking about things like, again, because agent go in and do a lot of steps, it's final result accurate. And if intermediate results and steps are accurate and make sense, while in consistency, it would be more from the side of, yes, while it use slightly different words to answer same or similar question, but is the meaning still the same? So there are things to consider, because you cannot just kind of get one response and then each next response compare like word by word if the response to evaluate if it's correct, not correct, okay, not okay. Another very, very large consideration is agent latency. If you remember the diagram where agent went and did something back and forwards, that's a lot of actions to be taken. And because of all this action to be taken behind the scene, and large language model by themselves have some latency. So when you send a request to the model, it did not provide the answer immediately. You need to consider that when you're building your agentic application or Gen AI application, because the more steps agents have to take, the longer it's going to take for them to provide you with final answer. And depending on what sort of application you're going to build, that might be like a deal breaker for you, where it will be go, no go to use that functionality in your application. Obviously, because it's machine, sometimes people have very high expectation that just because it's computer, it can do it instantly. And this is perceived responsiveness there, like it's a little bit slow, can be kind of uncomfortable. Again, you can think about how you can negate it in your user interface and make sure that user experience is still nice within that, technology limitations. Strictly speaking, depending on how complex your agentic workflow would be, and it's applicable to any Gen AI application, not AWS specific. If you have quite simple queries, you can expect with agentic workflow that is going to take 1 to 5 seconds. It is slow, like it's not instant. Where the more complex it becomes, the more time it's going to take. I would probably recommend to go and compare it to actual human doing a similar task and how long would it take, because if you need to go and go into different system, go find appropriate documents, it's going to take a while for human to do the same steps. So expectation of the system, just because it's done by Gen AI, being instance, is probably not exactly correct. But this is very, very big consideration of building a agentic workflow, because I think latency is one of the factors which is a little bit of prohibiting of getting a good user experience on output. Again, you build in your application, put a spinner, or don't say, okay, whatever, you're going to get it in your email later on. Managing that expectation helps a lot with building application. Last thing to consider is, while agent sounds cool and it's do a lot of things for you, just because it's cool technology, you don't always have to use it. Things to consider, there are other options. You don't have to use agents. Depending on what we're trying to achieve, you always have to go back to your use case and what's required for your specific use case. For example, again, because that's LLM cannot take action, being determined as one of the challenges. Companies who build in large language models start thinking about what can we do in this space. So quite a few providers nowadays have what they call tool use or function calling, where you can specify as part of your input to the model what other tools, APIs is available. And this would be given as part of input to the model. So model, while it cannot call these APIs, it is aware that it can get response from the APIs. So while it's going through that step-of-step process, it will stop and say, okay, I need to go and call that API. This is parameters I need to put as input into that API call. Go call that API for me and return the output of that API. And then once output is returned to the model, it can continue with its plan. So again, on Bedrock, you can use Converse API and with tool usage, which is built into the model specifically in some of the models. And instead of using agents, and get that capability of actually performing actions in your Gen AI application. Another thing to consider is, do you actually need to take actions, or you just need to request information which is very specific to your company and generate a response based on it? In this case, maybe retrieval generating RAG approach would be the kind of enough. And Amazon Bedrock has knowledge-based functionality, which is fully managed RAG solution on Amazon Bedrock, where you can provide connection to data sources, and with retrieve and generate API, get an answer based on your internal data sources. And another thing to consider is actually prompt flows, where you can put prompts in a specific order in a step-by-step workflow and automate specific business process. So if you have something which is very defined process within your business, using prompt flows can automate it and make it a bit more predictable, a little bit more determined than using agents, because you will specify how flow kind of performs step by step. Again, that has to be determined, where agent can be much more free in its performance. But depending on the use case and what you're trying to achieve, you need to decide which technology actually best suited for specific use case. So that's all from the slides. Probably took a little bit longer than expected. I do have a few resources available for you guys if you want to start experimenting with Gen AI agentic workflows on AWS. First of all, we have very good documentation of Bedrock service in general and agents in more specific, we have lots of blogs in this space, and they recently released a blog about best practices for building GenAI application with agents. And it's actually been just part 1 released, and part 2 is coming soon. We have a couple of workshops available for you to start playing around with. I have a couple here. The first one is more high level, where you kind of play around with console, where the second one is more in depth of a workshop for agents. Just if you do it in your own account, just be warned that, you know, if you use some specific resources, there are some charges applied. And for people who already play with a lot of this, we have GitHub repository of AWS samples, where people from around the globe on AWS have experimented some bits and pieces. And it's entire Bedrock samples repository, where you can go and pick about how to do specific thing if you know what you're trying to achieve in your GenAI application. Cool. Thank you very much for listening to me. And if you have any question, I would like to try to answer them.
Well, thank you so much, Nataliia, for that whistle-stop tour of agents. I'm sure it's a very deep and complex topic, but I think you helped simplify and break that down for us. So a big thank you for taking the time to put that presentation together. Yeah, so I'll open the floor now to questions from the audience. If anyone's got anything, just type it in the chat and we'll take it through from there. A question has already come in from Louisa. She's interested in real-world applications and examples, and what you use with your clients, and what did you learn from that real-world example. So yeah, the practical side of actual use cases, Nataliia, is there any particular types of agent, any particular types of problem that's are great for agents? And yeah, let's hear from you on that.
Yeah, one of the very good examples where like a RAG solution kind of will a little bit became popular a little bit earlier. Like I would say we have at the same stage with RAG solution last year as we have with agents this year. But what RAG cannot handle, even if it's specific information, but if it's real-time information.
Just to outline RAG for some people that might not know RAG as well. Sorry.
So fair enough. RAG is retrieval augmented generation, where you provide some context for the model with your question, so it can answer your question based on context. And it's usually very useful in situations where you have lots of documents, you know, like process documents written in natural language, which is very hard to search. So RAG solution will help you with the search part to identify the most appropriate documents to answer the question which came through, and then generate answer not based on the model, like learning and model knowledge, but based on like your proprietary data. Where it doesn't very fit very well is where you need to have access to real-time data. Some of the very good examples would be something like weather data, share prices data, because it's changing all the time. If you have the question about that specific data and want to generate answer on that specific, like where this information is very, very required, well, it's kind of based on data, but you need to get that information at that moment of time, where this function calling or agent is actually kind of fit perfectly. Because if you're asking, okay, I'm going on a trip to specific location in the next 3 days, what should I pack with me in my bag? It can go and check weather forecast for that location for next 3 days. And after it's determined, okay, that's going to be rainy, not rainy, sunny, hot, cold. And based on whatever wardrobe you mentioned you have with you, like available, it can generate you a list of things to take with you, sort of thing. That would be some of the examples. Again, agents are relatively new. All of this technology is very new, because if you think of it, it was 2 years ago, and it was start being quite popular around the globe. and it's moving so fast, it's changing so fast. I think people still experimenting a lot with it, and still a bit cautious because of non-deterministic outcomes of agents to put it actually in production and have it like fully productionized system with all these capabilities. But this is just example where you definitely can benefit from using some kind of agents or function calling to get to what you're trying to achieve.
Thank you. And so then that's a nice segue onto the next question about costs. Obviously, if it's non-deterministic, there might be some concerns that it might kind of get stuck in a loop and blow through your account, or also how much more expensive is using Bedrock over just using the OpenAI's direct API.
So if I go back to thinking about the diagram where it goes to the Bedrock, make a plan and start iterating on the plan, the cost of Bedrock, it's actually like agents and Bedrock by themselves don't cost you anything. The cost coming from interaction with the model when you send the prompt to the model, depending on how many tokens you send to the model and how many tokens the model return to you. If you use some kind of knowledge bases or lambdas, obviously this is underlying infrastructure, which is going to cost, that would kind of affect the cost of the solution. Obviously, there are some ways to limit how much, how much tokens model can produce in your API calls. And while the agent build, again, because that's a model which is managing all behind the scenes, it will cost more than if we just send the prompt to the model and it reply back to you, because you don't have a full control of what's going in and what's going out, because it's using LLM behind the scene to make a plan and execute a plan. From that point of view, if you go with tool usage, you probably have more control of the cost. But what I found on an experimentation state, it's not too bad, because you usually have, tens of fraction of cents per thousands or millions of tokens. On experimentation step, it tend to be quite reasonable. The question is, once you go to production and you know how much tokens it's consumed to perform the action of your agent, because again, you determine what your agent can do, how many APIs it can call, how complex queries it can handle. The production kind of step, this is where you would probably need to consider the cost and optimize on cost for the agent.
Okay, thanks. And we have a question through from Kath, looking at specifically using agents in healthcare. So have you got any thoughts for how agents could help with health and healthcare apps?
If you're talking about healthcare, obviously you have health professionals who've been trained and have a lot of training experience. And I personally don't think that it should replace the health profession. Like, I don't think that AI is replacing the health professional. It should help them do more productive and get to some things faster instead of spending time and writing reports. Healthcare, it's an interesting topic. From compliance point of view, while on AWS, Bedrock have quite a few compliance and with different, compliance program like HIPAA, GDPR, etc. Like, it's quite a few compliance, which is Bedrock itself and agents are compliant. But the question would be, when you build an application from shared responsibility model we have at AWS, you need to consider how you're treating customer data, not within the agent, but outside the entire application, et cetera, et cetera. So it is used in healthcare. I know it is using across the globe for healthcare customers, but with quite human oversight and observation to make sure that it stays within the boundaries.
Okay, well, thank you for that answer. We might have time for one or two more questions if anyone wants to put a last minute question into the chat. Also, if maybe Henry or Louisa have got another question, that'd be great. Otherwise, we might wrap up there. Okay, I'm not hearing anything from anyone, so I'll give you all 10 minutes of your day back. Once again, a big thank you to Nataliia. I'm going to press the heart button if I can. Here we go. I've not done this before. That work. There we go. Thank you so much, and we'd love to have you on again sometime in the future. So that wraps it up for today's Lunch and Learn session. Check us out at Tuesday for the In Real Life event, and we'll close off there. Thank you very much, everyone in the audience, for attending.
Thank you, everyone. Thank you, Andy.
Goodbye.